Consider next problem for epsilon NFA to NFA without epsilon moves conversion. So the first step is to identify unreachable states and remove them. So from P we can reach Q, S, U, and then R, T, V, all the states are reachable. In next step we calculate epsilon closure for each state. Now we will start with U. From U we do not have any epsilon move. So epsilon closure of U contains only U. Similarly, epsilon closure of V, it contains only V. For S, first it will contain the state itself and then S on epsilon goes to U. For state T, first it contains state T itself. From T on epsilon we reach to state V. Now for state Q, there is no epsilon move. It will contain only state Q. Similarly for state R, it will contain only R. P, first it contains P itself and then on epsilon it will reach to Q and R. Now for state Q, we have to consider epsilon closure of Q. It contains only Q. We do not have to add anything. For R also, epsilon closure contains R. We do not have to add anything more. This completes epsilon closure of all the states. Now we will start with calculating transition table for NFA without epsilon moves. So first we have to consider epsilon closure of the state, then transition for 0, and then again epsilon closure for the state for the transition. Consider state P. Epsilon closure of P contains P, Q, R. P on 0, there is no transition. Q on 0 goes to S. R on 0, there is no transition. Now epsilon closure of, here we do not have any state, so we mark it empty. For S, epsilon closure contains S comma U. Here we do not have any transition. Now similarly we have to consider epsilon closure transition on 1 and epsilon closure for the transition state. So epsilon closure of P is P, Q, R. P on 1, no transition. Q on 1, no transition. R on 1, R on 1 goes to T. Now we have to consider epsilon closure of these states. So empty, empty. Epsilon closure of T contains T comma V. Next state is Q. Epsilon closure of Q contains only Q. We write it at both places, for 0 also, for 1 also. Q on 0, it goes to S. Epsilon closure of S, S and U. So here we write S and U. For Q, Q on 1, there is no transition, so we write empty set over here. Next state is R. Epsilon closure of R, it contains only R. We write it at both places. R on 0, there is no transition. R on 1, it goes to T. Epsilon closure of T contains T and V. So we complete transitions for R. Next state is S. Epsilon closure of S contains S and U. S and U, we write at both places. S on 0 goes to U. U on 0, there is no transition. Epsilon closure of U, it contains only U. Here we don't have any entry. S on 1, there is no transition. U on 1, it goes to U. Epsilon closure of U, it contains only U. Next state is T. epsilon closure of T contains T and V. We write it at both places. T on 0, no transition. V on 0 goes to V. Epsilon closure of V contains only V. T on 1 goes to V. V on 1, no transition. Epsilon closure of V, only V. Now U, epsilon closure of U, it contains only U. We write it at both places. U on 0, no transition. U on 1, it goes to U. Epsilon closure of U contains only U. And then state V, epsilon closure of V contains only V. V on 0, it goes to V. Epsilon closure of V contains only V. V on 1, no transition. So there is no transition. So here we complete transition table for NFA without epsilon moves. Now we will draw transition diagram. Now when we convert epsilon NFA to NFA, the states remain the same. We have to calculate transitions. Initial state remains the same. We have to calculate final states. Existing final states, they also remain final state. But in addition to that, we have to calculate final states considering epsilon closure and epsilon transitions. So first we will draw the transitions. In given in epsilon NFA, final states contain state U and V. Now consider transitions for P. P on 0 goes to S and U. P on 0 goes to S and U. P on 1 goes to T and V. P on 1 goes to T. P on 1 also goes to V. Q on 0 goes to S and U. Q on 0 goes to S and U. Q on 1, there is no transition. R on 0, there is no transition. R on 1 goes to T and V. R on 1 goes to T and V. S on 0 goes to only U. S on 0 goes to U. S on 1 goes to U. S on 1 goes to U. This is the transition for S on 1. T on 0 goes to V. T on 0 goes to V. T on 1 goes to V. T on 1 goes to V. U on 0, no transition. U on 1 goes to U. U on 1 goes to U. V on 0 goes to V. V on 1, no transition. V on 0 goes to V. There is no transition for 1. So this is the NFA, equivalent NFA without epsilon transitions. And if you have observed that state Q and state R, they are not reachable. We still have to mark final states. Now final states in epsilon NFA, they are U and V. So we have to check which epsilon closures contain U and V. So state S, it contains U. So state S, we have to mark as final state. For any state, if in its epsilon closure, if it contains at least one final state corresponding to given epsilon NFA, we mark that state as final state. State S contains U, which is final state in epsilon NFA, we mark S as final state. Then V is over here, so state T, we have to mark final state. U, it contains U, it is already marked. V, it contains V, it is also already marked. So when we convert epsilon NFA to NFA, number of states remain the same. Initial state in NFA is same as initial state in epsilon NFA. In this case, after calculating the transitions, we find that some states are unreachable. And regarding final states in NFA, we have to consider the calculation. First, you consider final states of epsilon NFA. Then you consider epsilon closure. In any epsilon closure, if you find at least one final state corresponding to epsilon NFA, then that state is marked as final state in the NFA.